Determine f702 of x, the 702nd derivative of x, for the function f of x equals sine of 2x. Then evaluate f702 of pi over 12. So my function, sine of 2x, has a first derivative that will be cosine of 2x, leave the inside alone, and then multiply by the derivative of the inside, 2, to complete the chain rule. 2 cosine 2x. A second derivative, the 2 comes along, the derivative of cosine is negative sine, leave the inside alone, multiply by the derivative of the inside to complete the chain rule. And we have negative 2, and I'll write it as 2 squared instead of multiplying the 2, so we can start to discern a pattern here. The third derivative will be the negative 2 squared comes along. With this, the derivative of sine is cosine, leave the inside alone, then multiply by the derivative of the inside to complete the chain rule. So we have negative 2 cubed cosine of 2x. The fourth derivative will go to negative 2 cubed, the derivative of cosine is negative sine, leave the inside alone, 2x, but then multiply by the derivative of the inside for the chain rule. We have a double negative. The two negatives multiplying will become positive. I have 2 cubed times another 2 that will move to the front, so 2 to the 4th, and then sine 2x. It has returned to a sine function, but it does have a 2 to the 4th in front of it. We want to try to discern a pattern here, and the pattern happens every fourth derivative. Well, here's the thing. The first derivative has 2 to the first power. The second derivative has 2 to the second power. The third derivative, 2 to the third power. The power matches the order of the derivative that we're taking. The fourth derivative has 2 to the 4 power. That means the 4n derivative will have 2 to the 4n. And because every fourth derivative returns to sine, 4n will return to sine. This is where n is a positive integer. Now what we want for our problem is the 702nd derivative of x. Well, 702 is not divisible by 4, however 700 is. And so what we can do is write this as the 700 derivative in square brackets and then take 2 more derivatives with 2 primes. By being the 700 derivative being divisible by a 4, we can make use of the pattern. We will have 2 raised to the order of the derivative, 700, and then it will have returned to sine of 2x by being a divisible by 4 type of derivative. It cycles every fourth derivative. Now what we want is 2 derivatives beyond here, so now we're going to actually take the derivatives. 2 to the 700 is just a constant. The derivative of sine is cosine of 2x, leave the inside alone, multiplied by the derivative of the inside to complete the chain rule. We have 1 more prime left, but before I take that, let's move this 2 out with these 2's, and that'll just raise that power to 701. And then we take another derivative from here, so we have 2 to the 701 times the derivative of cosine is negative sine, leave its inside alone, and then multiply by the derivative of the inside to complete the chain rule. We have no more derivatives left. I will move the negative to the front, and I will put the 2 here with the 2 here, so it'll be 2 to the 702, and sine of 2x. There's our 702nd derivative. Now we want to evaluate that at pi over 12, which just means to plug a pi over 12 in for any x's. So we have negative 2 to the 702 sine of 2 times the x, so 2 times pi over 12, 2 pi over 12. We'll reduce that. So we have negative 2 to the 702, 2 pi over 12 can reduce to pi over 6. Sine of pi over 6 is 1/2. And we can multiply the numerators, so we have negative 2 to the 702. Multiply the denominators, we just have a 2 in the denominator. And we can actually combine those by subtracting the exponents, because the denominator is 2 to the 1, the numerator is 2 to the 702. And we can combine them. 702 minus 1 is 701, so it's negative 2 to the 701.